Start.
Okay. For my bio lab, I did natural selection. And for the first questions, which conditions that are necessary for the Hardy-Weinberg equilibrium were not met? The ones that were not met were there were no mutations, there was no migration of another species of mice, and matings were random, so that wasn't one of them. And the population was only 100 mice, when in real life it would probably be much larger, looking at like 1,000 or more mice. So for the second question, which condition was changed? The survival rate of the lighter colored mice was changed over time because they started with a 90% survival rate, but being on black rocks, that dropped very quickly because predators can see white on black very easily. And then briefly describe the scenario that I simulated. So the light colored mice were easily seen by predators, thus the light gene was lost. So over time, the dark colored gene was only 10% of my population, but it grew and grew and kept growing because the dark colored mice were very unlikely to be eaten by a predator. So they had a very high chance of mating and producing offspring. What were your predicted results? My predicted results were that the darker colored mice would most likely do better on the darker colored rock, and that the lighter colored mice would do better if they were on lighter colored rock. How many generations I do in my stimulation? I did 6 because once I got to 6, my results were going to be the same every time. Describe the changes of allele frequencies P and Q over time. Did your results match your predictions? So yes, they did match, and over time the dark colored furred mice took over the population, and eventually the majority of the population, to all the population, became homozygous AA for the dark colored gene. Describe the changes in genotypic frequencies. The mice genotypic frequencies went from 90% of them were homozygous a, to then it went to almost 50% heterozygous big A, to eventually they went to all AA, which was the dark colored fur, because the light colored fur was just not doing well for them on dark colored rock, and eventually that gene died out and went away. Compare your allele and genotypic frequencies to those of the starting population. They do almost an entire 360. My population started with 90% light colored mice, and by the end was 100% dark colored mice. So it's completely flipped. So formulate a general summary statement or conclusion. My conclusion was the genotype AA was most beneficial in this environment. Even with few dark coat descendants in the beginning, this trait eventually took dominance over the population. And for number 6, graph the changes of P over Q over time on a graph. So I just have a whiteboard here, so I did it again, and you can see how it started with mostly light colored mice, and that dropped off down to 0, and how it started with only 10 dark colored mice, which continued for a few generations, but then shot all the way up here to almost 100%. All right, thank you. That's it.